Now it's time to talk about factoring common factors, which is an operation that we frequently do on polynomials to make them easier to work with. The first thing to understand is that factoring is the opposite of the distribution property that we've already discussed. If you look at these two examples, if we were going to distribute in the first example on the left, we would take the 5 and multiply it times each term in the parentheses. So let's go ahead and do that. This would be equal to 5 times x squared plus 5 times 2x plus 5 times 3. Now we can do these individual multiplications and get our result. 5 times x squared is 5x squared. 5 times 2x is 10x. And then 5 times 3 is 15. Notice that the result we ended up with is the exact same as the expression we're looking at on the right-hand side here. The goal with this right-hand side is going to be to start with this and then see if we can reverse the process we just did and end up with the original expression over here on the left. Notice that the terms on the right-hand side here all have something in common. They're each divisible by 5. 5x squared is divisible by 5, 10x is divisible by 5, and 15 is divisible by 5. That gives us a clue that a 5 is something that we'll be able to factor out here. So when we rewrite our expression, we're going to have a 5 on the outside of the parentheses, and then some other expression left over inside the parentheses. The question is, how do you figure out what terms are left over inside? Well, if you look back at the example on the left, the way we got from the original expression to the distributed expression was by multiplying, right? We multiplied the first term, we multiplied the second term, we multiplied the third term. And so if we're going to reverse that process, it would make sense that division is involved somewhere, and this is the step where division comes in. The way to figure out what gets left over inside the parentheses here is take each term in the original expression and divide it by the thing that you have factored out. Our first term was 5x squared, and so to figure out what's left inside the parentheses, we're going to divide that by 5. Well, that just turns into x squared. Our second term was 10x. We're going to divide that by 5, and that leaves us with 2x. And then the last term was 15, and we divide that by 5, and we are left with 3. These are the 3 terms that are left over inside of our parentheses. X squared plus 2x plus 3. Notice that we ended up at the exact same place where we started on the left-hand side. So factoring and distribution really are opposite operations. Let's do a couple more examples of factoring out a common factor. In the first example, we have 12x to the third plus 18x squared plus 30x. We first need to determine what term we're going to factor out of our expression. In general, we want to factor out the largest possible term that we can. We usually refer to this as the greatest common factor, or we sometimes abbreviate it as GCF. There's going to be 2 parts to this. There's going to be the number part, the coefficient, and there's going to be the variable part with a power. So in terms of the coefficient, we have a 12, we have an 18, and we have a 30. And what we need to find is a number that will divide each of those 3 numbers. Well, if we think about it for a little while, 6 will do the job. 6 divides 12, 6 divides 18, and 6 divides 30, and there isn't any bigger number than that that will also divide all 3. So 6 is the coefficient part of our GCF. For the variable part, we look at each term and we see how many copies of the variable we have in each case. X to the third here means we have 3 x's. X to the second here means we have 2 x's, and x here means we have just 1 x. So what do we have in common? We have one x in each that we can factor out. So x is going to be the variable part of our common factor. So this tells us that our factored expression is going to have 6x on the outside of the parentheses, and then it will have something on the inside. The way that we determine what terms are left inside is through a division. We take each term of the original expression, and we're going to divide it by the term that we're factoring out. So in this case, that's going to leave 12x to the third divided by 6x. And then we will also have 18x squared divided by 6x. And then we will also do 30x divided by 6x. In the first expression, 12x to the third divided by 6x gives us 2x squared. In the second expression, 18x squared divided by 6x leaves us with 3x. And in the last one, 30x divided by 6x is just 5. These are the terms that will be left over inside the parentheses. 2x squared plus 3x plus 5. Now let's look at the second example. We have 15x to the fifth plus 90x to the third plus 60x squared. Our first task is going to be to identify the greatest common factor. So we're looking for a number that divides 15 and also divides 90 and also divides 60. Well, if you think about it for a minute, 15 will do the trick. 15 is divisible by 15, 90 is divisible by 15, 60 is divisible by 15. For the variable part, we need to look and see how many x's we have in each term. In the first term, we have 5 x's. In the second term, we have 3 x's. And in the last term, we have 2 x's, which means that we have at least 2 x's in each term. And so x squared is going to be the variable part of our greatest common factor. So now we know that our factored expression is going to look like 15x squared on the outside of the parentheses, and then some other expression on the inside. Once again, we're going to divide each term of the original expression by the thing we're factoring out to figure out what's left inside the parentheses. So for the first one, we have 15x to the fifth. We're going to divide by 15x squared. For the second, we have 90x to the third that we're going to divide by 15x squared. And for the last one, we have 60x squared, which we're going to divide by 15x squared. For the first one, we have 15x to the fifth divided by 15x squared leaves us with x to the third. For the second one, 90x to the third divided by 15x to the second power is 6x. And then for the last one, 60x squared divided by 15x squared is just 4. So these are the 3 terms that are left over. X to the third plus 6x plus 4. The last thing we're going to discuss is factoring by grouping, which is a slightly fancier version of factoring out a common factor. If you look at the first example, we don't have anything in common across all 4 terms here that we can factor out. If you notice, we do have a 5x and a 3x here that we could combine as like terms, but that's not the goal in this case. Instead, let's look at the left-hand terms and the right-hand terms separately and see what we can factor out of them individually. Looking at the left-hand terms, we have an x squared and we have a 5x. So that leaves us with an x in common between those. Let's factor it out. That's going to be x parentheses x plus 5. Now looking at the right-hand terms, 3x plus 15, we have a 3 in common that we can factor out. So let's do that. Plus 3 parentheses x plus 5. The thing to notice about this result is that we have an x plus 5 being multiplied at the first term, and we have an x plus 5 being multiplied by the second term. So what that means is we can give it the same treatment that we did the common factors in the last case. We can take our x plus 5 here and factor it out. What does that leave us with? We're going to pull out x plus 5, and what's left over? The way we determine what's left over is by dividing each term by the thing we factored out. X times x plus 5. We're going to divide that by x plus 5. And we're left with just x. And then for the second one, same idea. 3 times x plus 5. We're going to divide that by x plus 5. And we're left with just 3. So we've taken the 4 terms that we had in the original expression here, and we have factored it into 2 binomials multiplied together. Now let's do the same thing for the second example. Once again, we have 4 terms here, but we're going to look at the left-hand terms and the right-hand terms separately and factor them individually. For the left-hand part, we have a 3x to the third minus 7x squared. The only thing that we have in common there that we can factor out is x squared. And if we do that, we will be left with 3x minus 7. Now looking at the right-hand terms, we see that we have a 4 in common between those that we can factor out. So that's going to be plus 4 times 3x minus 7. Just like the last case, you should notice that we end up with the same term here and here, which means, again, that we can factor it out. So what do we end up with? Well, we're going to have 3x minus 7, and then what's going to be left inside the parentheses? The stuff that's left inside the parentheses is the stuff that was just outside the parentheses, x squared plus 4. And so once again, we have taken our initial expression, which had 4 terms in it, and we have factored it into a product of 2 binomials.